Good evening and welcome to tonight's virtual open house. My name is Kelsey Perry. I'm Mayflower Wind's Community Liaison Officer, and I will be your moderator for tonight's event. First, I'd just like to thank you all for taking the time out of your evening to join us to learn more about the Mayflower Project and our activities in Portsmouth and Somerset. We had almost 300 registrants for tonight's event, most of you coming from the South Coast region, and we're grateful for such a great turnout. Thank you also to the elected officials, as well as the local, state, and federal agency members in the audience tonight who made the time to join us. As a reminder, this event is exclusively focused on Mayflower Wind's South Coast project, and we will be focusing on addressing questions coming from the Portsmouth and Somerset community members. For those of you who aren't familiar with Mayflower Wind, we're developing an offshore wind lease area 30 miles off the coast of Martha's Vineyard and about 20 miles off the coast of Nantucket, with the potential to generate up to 2,400 megawatts of clean, renewable energy, which is enough to power over 1 million homes and businesses across New England. Once in operation, the project will eliminate up to 4 million tons of greenhouse gas emissions annually, making it one of the largest contributors to emissions reductions in the region. Tonight, we will be giving you a virtual 3D tour of our South Coast project from the offshore lease area, intermediate cable crossing in Portsmouth, Rhode Island, to the onshore facilities in Somerset, Massachusetts. This is the fourth event in our open house series titled The Future of Clean Energy is Here. Here's tonight's agenda. First, we will give you a high-level overview of the Mayflower Wind project, including the environmental and economic benefits, as well as the project's projected timeline. We'll then dive into our virtual tour of the Mayflower project, including the offshore and onshore components. And there will be 3 stops along the way to ask questions. Here are tonight's speakers. As mentioned, I will be moderating tonight's event. We have Chris Hardy, our external outreach manager, who will be our main speaker and tour guide. We have our new community liaison officer, Dugan Becker, who's driving the 3D visualization tool behind the scenes. And we also brought in some of our internal experts this evening to participate in the question and answer segments. We have Joel Southall, our fisheries liaison officer, Lawrence Mott, our transmission development manager, and Tim Ryer, our export and inter-array cable lead. I can now hand it over to my colleague, Chris, to kick off the presentation.
Thank you, Kelsey. Good evening. I'm Chris Hardy. And before heading off on the 3-dimensional tour, we want to cover some of the overall broad context about Mayflower Wind. Let's start with the grid, though actually in the tour, it's where the Mayflower Wind South project ends. The New England power grid is in transition from fossil fuel to clean energy based. More than 7,000 megawatts of fossil fuel nuclear power plants have already or expected to retire and will be replaced by clean renewable energy. The transition to a net zero carbon future calls for new generation to power the electrification of our heating and transportation sectors. Mayflower Wind is repurposing the existing grid connection at Brayton Point, where southern New England's largest coal plant operated for a half-century. Offshore wind will offset the need for imported fossil fuels and enhance the limited energy supply mix available to serve the regional electric load. How? Offshore wind provides a stable, cost-competitive price while helping to achieve reliability, environmental, and economic development goals. That's why New York and the New England states have issued procurements for offshore wind as the least cost pathway to decarbonization for over 9,000 megawatts to date. The projects that have earned the power purchase agreements are located in this colorful stack of offshore lease areas. There are 7 active lease areas and 4 different sets of competitive joint venture owners. Each leaseholder seeks to generate as much of the potential from their individual resource area while minimizing environmental impacts and costs. The megawatts of electricity generated from all of these offshore wind projects feed into the grid in coordination with other sources, subject to the oversight of the regional grid operator. With its close proximity to the offshore wind energy areas, maritime workforce, and port infrastructure, the South Coast region is well suited to attract an offshore wind cluster, well-paying jobs and investments. Fall River and New Bedford will anchor Mayflower Wind's activities during project installation and operations. Our existing office at 99 South Main Street is just a short walk to the Fall River waterfront, where our new Operations Maintenance, or O&M port, will be located at the Boarding Remington property. It's a convenient drive from the office or the O&M port to Somerset, Portsmouth, and New Bedford. The New Bedford Marine Commerce Terminal will be the primary staging and deployment base during the project's construction. Several hundred permanent, high-quality, long-term jobs will operate and maintain the offshore wind farm, all based at the Fall River O&M port, the majority traveling out to the offshore wind lease regularly, either on the service operation vessel, which is more kind of like a floating hotel, or on the New Bedford base crew transfer vessels that will shuttle back and forth on a daily basis. Mayflower Wind's investments create spillover benefits and opportunities across the region. Let's start with those crew transfer vessels. Through a multi-party collaboration, an industry-leading Jones Act compliant hybrid crew transfer vessel will be designed and constructed at Gladdingherne's Somerset shipyard. This is not just an agreement with the local shipyard, it's the integration and launch of that shipyard into a new global market. Similarly, we're an active supporter and contributor to Southern New England Blue Economy initiatives led by leading institutions like the University of Rhode Island and UMass Dartmouth that tap the region's competitive advantage for global innovation and growth. And we encourage partnerships between Rhode Island and Massachusetts organizations to leverage the $115 million in investment commitments made through the recent procurements for other supply chain and workforce efforts. Mayflower Wind aims to deliver clean energy from the project by the end of this decade. Right now, we're in the permitting phase. The state-level reviews by the Massachusetts and Rhode Island Energy Facility Siting Boards, or EFSB, are two key processes that drive state and local permitting timelines. The EFSB is an independent state board that reviews proposed large energy facilities to determine if they serve the public interest. Following the state EFSB reviews, Mayflower Wind will work cooperatively with the towns of Portsmouth and Somerset to seek licenses. Permitting applications and materials can be found on the Mayflower Wind website. Installation and construction will begin once permitting and financial obligations have been met, which is expected by the middle of this decade. So by the end of this decade, Mayflower Wind is responsible for the generation and delivery of 1,200 megawatts to the Brayton Point grid connection. National Grid will be responsible for permitting, constructing, and operating its receiving substation. And from there, an interconnected network of transmission and distribution lines ultimately deliver power to customers like you. Now tonight, with the use of three-dimensional modeling and animated sequences, we want to provide a realistic visual experience of this offshore to onshore connection. Let's head off. So we look down as though from a satellite, the offshore lease area, which, as Kelsey mentions, has the power capacity to generate enough power for nearly 1 million homes, is located 30 miles south of Martha's Vineyard and 20 miles south of Nantucket. The project will occupy the entire 199 square mile lease area, which was awarded through a competitive auction by the United States Bureau of Ocean Energy Management. By pursuing dual delivery points, 1,200 megawatts to Falmouth to the north in green, and 1,200 megawatts to Brayton Point to the northwest in orange, Mayflower Wind can maximize the full generation potential of the offshore lease area. Now, as we zoom into the lease area, the site layout for an offshore wind farm depends on a variety of factors. The seafloor shape, shipwrecks, boulders, other features impact where facilities can be placed. Water depths in relation to mean low or low water range from about 120 to 200 feet, with deeper waters in the southwestern portion of the lease area. The lease area has 149 positions to install wind turbines and multiple offshore substation platforms. The positions all conform to a uniform 1-by-1 nautical mile grid layout with east to west and north to south orientations across the entire New England wind energy areas, as agreed upon by Mayflower Wind and all the other leaseholders. This layout creates more distance between turbines than any offshore wind project operating in the world, establishing more than 200 transit lanes in all directions. The United States Coast Guard determined in its 2020 port access route study that this standard and uniform grid pattern would maximize safe navigation through 7 adjacent wind farm leases covering more than 1,400 square miles of ocean. Now, fishing and boating activities will be allowed to continue as permitted in the project area, though there may be some temporary safety zones during construction. Let's take a closer look at the wind turbines, which convert kinetic energy from the wind into electric power. Mayflower Wind is selecting wind turbines based on available technology and feasibility. There are trade-offs. Generators with larger rotor diameters create more power, but they require larger foundations to accommodate their larger size. And of course, they generate more power, excuse me. The turbines have blade lengths of 350 to 450 feet, or about a football field long, and the hub heights of about 400 to 600 feet above mean lower low water. Mayflower Wind will implement an aircraft detection lighting system, or ADLS, to reduce the amount of lighting compared to the traditional always-on lighting system in alerting air traffic. Now, the design standards for offshore wind farms are based on lessons learned from turbines and offshore oil platforms that have survived a spectrum of natural disasters in Europe, Asia, and North America, from hurricanes and typhoons and other situations. Cold climate weatherized turbines have operated regularly in frigid conditions throughout North America and Europe. Supporting the wind turbines below are the foundations and substructures. Mayflower Wind is considering 4 substructure options, including monopiles, pile jackets, suction bucket jackets, and gravity-based substructures. Depending on the substructure option used, the foundations could extend to a depth of up to 295 feet below the seabed. Shown here are the monopile and now the jacket substructure options. Let's go visit one of the offshore converter station platforms. There will be multiple platforms in the Lease area. Now, like the turbines, the design for the offshore substation platforms hasn't been determined yet. These platforms serve several functions. They're collection and termination points for the inter-array cable system that connects individual wind turbines through a series of submarine cables operating at 69 kilovolts. The offshore converter substation steps up and then converts that voltage up to 320 kilovolts plus or minus as its DC direct current for export to the onshore converter station. You may wonder how tall these are. Depending on the model that's used, the topside height would be anywhere from 160 to 345 feet, or about as least as tall as the Statue of Liberty, above the mean low water level. Now, finally, the platforms are the starting point for the export cables that take the power to the onshore converter station. Let's go take a look at the export cable corridor that crosses northwest from federal and state waters through Rhode Island Sound and up the Sakonnet River. The expected distance from the offshore platforms to the onshore station is between 97 and 124 miles. We'll be using high voltage direct currents, or HVDC technology, which allows for more power to be transmitted with fewer cables and less power loss across this scale of distance. We plan to install 2 submarine cables and 1 dedicated telecommunications cable within the cable corridor. Now, each cable is about 6 inches in diameter, and it would be buried at a depth of about 6 feet below the seabed. The cables will be installed together in a bundle to minimize the overall footprint where practicable. Over the past couple of years, you may have seen multiple vessels conducting geophysical and geotechnical surveys. These surveys provide data about the seafloor and the subsea for evaluation in the project design and permitting process. As you can see now, we've arrived just offshore Quidneck Island. Before we move on to the intermediate landfall and the onshore work, let's take a break to answer a few questions about the offshore aspects of the project.
Great, thank you, Chris. So our first question here is for Lawrence. It's how do severe storms and high winds and seas impact the offshore wind turbines?
Thank you, Kelsey. Appreciate it. Offshore turbines are designed and certified to operate in their environment. They have been operating in North Sea offshore situations for over a decade, onshore in some very tough extreme environments for over 3 decades. The waves for the foundation considerations, when we look at what's called mid-ocean, combination of wind and waves and the steepness and waves, all the attributes that fishermen and other mariners understand, these turbines will continue to generate up to 25 meters per second or 55 miles per hour, which is important that during tough conditions, they are still generating and putting that energy into the grid. And then they'll go into a safe mode during a hurricane to protect themselves and be ready to operate again once the conditions are appropriate.
Perfect. Thanks, Lawrence. Here's a quick question for Joel. Will we be able to fish in the lease area?
Yeah, thank you for that. And that's a really important question and a really good question. So the answer to that is yes. So that's one of the unique things about the development of offshore wind here, is that the ability to fish will continue in the lease area. Like Chris said, there may be some temporary sort of rolling safety zones during the construction period, but after that, there will not be any restrictions on fishing.
Great, thanks, Joel. Here's a couple more for you. What is Mayflower going to do to make sure that whales and other marine mammals aren't harmed during this process?
Yeah, thank you. So one of the things I would say is Mayflower and other offshore wind developers developed something called a construction and operations plan that has a lot of really good information that's publicly available. So if you just search for Mayflower Wind COP or construction and operations plan, that takes you to a lot of really good information, including things about protections that are in place, mitigations that are in place for protected species, and to make sure that all of the construction, operation, and decommissioning of the project ensure that protection is in place, and also that it complies with all of the applicable regulations.
Thanks, Joel. Here is one more for you, a related question. Will construction be suspended during times of high migration for species like whales, shark, fish, etc.?
Yeah, so that's one of the things where at the stage of the project where we are and where we are in the permitting process, that is something that is being developed. So how the timing of construction works around things like migrations, feeding patterns, as animals move through or stay in the lease area, the construction zone, that's something that we're working on very closely with conservation groups, with different parts of the government as we go through the permitting process. Some of that's outlined in our construction operations plan that I was talking about, but a lot of that is being done as we go through the later stages of the permitting process. So it's that permitting process is it's a fairly lengthy, very robust process that has a lot of milestones. And as all of these developments, including Mayflower Wind, go through that, that's something that is ahead of us there. And one quick thing I wanted to say was, in addition to working with different parts of the government on that, we work with conservation groups, and through a couple of different projects we have are supporting a lot of research to better understand things like migration patterns, but also just movements of highly migratory species of fish, and how marine mammals also utilize, move through, and are sort of in and around the lease area.
Thanks, Joel. We have time for one more question in this session, but just a reminder, please feel free to send your questions anytime. We will get them, and we'll try our best to get to all of them in all three of the Q&A sessions. This last question is for Tim. What type of scour protection will be applied over the export cable?
Yeah, thank you for that question. So scour protection material, which would expect it to be material such as rock, may also be used at the offshore foundations, around the foundations, to ensure long-term integrity. Along the cables, secondary cable protection such as rock or mattresses may either be used at pipeline or cable crossings, in case the cable can't be buried for any reason, although we do intend to bury the cables in the seabed along the entire route if possible. So we're considering materials such as rock or mattresses, but the selection of specific material may depend on the seabed conditions at the particular location that it would need to be used.
Perfect. Thanks, Tim. And back to you, Chris, for the next part of our tour.
Thanks for the questions. Before we move on ahead to the intermediate, approximately 2-mile long crossing at Aquidneck Island, I wanted to address a few questions. A number of people have asked if Mayflower Wind could avoid the landfall entirely and route the cable up the northern Sakonnet River. Others have asked about trying a western approach through Narragansett Bay. And when looked at closely, there are numerous constraints and physical obstacles at either of these approaches. If we start on the western side, the Western Passage, you're looking at a longer route with more impacts. As we look at the west of Aquidneck Island, there are U.S. Navy activities. Now, I want to reserve time for some discussion with my colleague Lawrence regarding the northern end passage, but it's fair to say that there's a narrow river channel with strong and swift currents and a heavily scoured seabed with submerged obstacles and a history of debris that's been left in place. These obstacles eliminated the fully offshore cable routes from consideration. So from about a half-mile offshore, the cables will make entry landfall near the intersection of Boyd's Lane and Park Avenue. Mayflower Wind will use horizontal directional drilling, or HDD, for the entry and exit cable landfalls. HDD is a trenchless process that enables the cables to go deep below the street, the beach, the intertidal zone. And using HDD helps avoid impacts to nearshore resources on both the Island Park side and the Mount Hope Bay side, such as the eelgrass beds, docks, the mooring fields, the recreational beach area, and the people and the wildlife that they support. Each of the proposed power cables follows a trajectory that's sort of shaped in the form of an arc. Each is about 0.3 to 0.6 miles in total length, reaches a depth of approximately 40 feet below the ground in the seabed, though it's shallower as the cable reaches the surface. Each cable path is separated by about 16 to 32 feet. We're going to now show you a drilling sequence from the Falmouth project, though a similar approach will be used at Portsmouth. The first step we're observing is the sound wall being erected around the entry site to minimize construction noise impacts. The site is being prepared by digging a temporary pit to contain the drilling mud. Now a HDD drilling rig is drilling the pilot hole under the surface. And then under the seabed. As you can see, it follows that arc until it meets the barge offshore, where the conduit that's made up of high-density polyethylene or plastic piping is pulled through each borehole. And then that's followed by a steel armored cable. And once ashore, the cables continue. This is the last aspects of the Falmouth project. So some of this will not be applicable to the Portsmouth project. So we'll switch back. Great. So the cables will continue under state municipal roadways along one of a few potential routes for about 2 miles until reaching a potential exit landfall into Mount Hope Bay. We have several potential HDD exit locations, including near the Mount Hope Bay Bridge. Okay. At the Roger Williams Bay Point Residence Hall and in the existing utility easement. And then at the Mount Top Country Club parking lot. Shown here now are the potential underground routes from the entry to one of the potential exit points. Any cable trenching between the entry point and one of these exit locations would likely consist of a single large trench where the cables would be pulled through a duct bank. Alternatively, the cables could be installed by directly burying them in the road and then backfilling them without a concrete encasement. Now, I mentioned earlier there's a telecommunications cable, and they will be installed within the same underground system. Now, we understand that the town of Portsmouth and surrounding communities are interested in expanding broadband communications infrastructure, and we're willing and open to exploring feasible and prudent opportunities to support this local need. Now, in-road construction would occur outside of the busy summer season to the extent practicable. Partial lane closures with alternating traffic patterns might be required during construction. Temporary noise barriers and equipment silencers would be installed at each of the HDD points. Construction activities will comply with the Portsmouth noise ordinance. Let's take a pause now and take any questions about HDD, the Portsmouth entry and exit landfalls, and the onshore routing options.
Great, thanks, Chris. This first question that we received, I actually think I'm probably the best person to address it. What is Mayflower Wind's plan to ensure that environmental justice communities and traditionally underrepresented communities are not left out of the economic benefits of the offshore wind boom? Great question. So to start, to engage with the local community and environmental justice communities, Mayflower has and will continue to work with the Director of Environmental Justice Communities to ensure appropriate measures are taken to address any potential impacts to environmental justice communities from this project, and to make sure we're engaging them about these benefits. There are a bunch of different measures, from identifying applicable languages that we should translate our public notices into, scheduling public meetings at locations and times that are convenient, and putting an effort into making sure our investments go to the right place. One of our programs I think that's good to highlight is our new Protected Species Observer Training Program with RPS. We're working with RPS to train local Native American tribal members to become protected species observers. This is cost-free training, and they will receive all certifications required to then be employed as a PSO, protected species observer, on offshore wind survey vessels, other energy development projects. So that's just one small thing that we're doing to try and get, populations who aren't traditionally part of the energy workforce, part of this new workforce. And I'd recommend actually looking into our January 27th open house, when we went over a lot of our economic benefit initiatives, and that's available on our website. So back to the questions, the other questions, sorry, just sorting through here. So for Lawrence, here is one for you. In a more shallow area such as the Sakonnet River and Mount Hope Bay, are there implications for electromagnetism or EMF from cables affecting the wildlife or life cycles in our project area?
Thanks, Kelsey. The benefits of burying the cable in mud are firstly support negating any of the EMF impacts. Secondly, the jacket around the cables themselves further insulates. And lastly, the use of DC technology is less in its EMF impacts. So to wildlife, I think it's important that, I think the question included studies. Yes, there have been quite a few active studies, specifically in Long Island Sound nearby, on impacts to creatures, and specifically quahogs, lobsters, crabs, and others in this environment. And no definitive impacts have been seen. It is part of the ongoing process as Joel leads on evaluating and considering this all the way through the formal permitting process.
Perfect. Thanks, Lawrence. Here's a quick one for Joel. So will these offshore wind turbines, the size of the Empire State Building, be visible from onshore?
Yeah, so it depends on where onshore you're talking about. So from the area we're looking at here and the area we're talking about, no. So the closest turbine is about 70 miles away from Portsmouth, which is about as far as Portsmouth is away from New Hampshire. There are some points on Nantucket where some of the turbines are visible depending on conditions. So not from here, but there are some points on some shores where some of the turbines are visible.
Thanks, Joel. Here's one for Lawrence that has to do with climate change and sea level rise. How will climate change and then consequential sea level rise impact the project, both during construction and later on?
Well, importantly, and for me personally, why I'm involved in offshore wind, it is one of the most impactful energy supplies to reduce climate change. And so we're really offsetting significant amounts of carbon with these large projects offshore. As to impacts during construction and operations for construction, similar to some of the wildfires and storms, we may have to be a little more on our toes as we plan for construction windows and avoid storms that are more frequent. And then long-term, the project will be designed for current expectations of continued rise. So we will be elevating the converter station at Brayton Point slightly and take other actions to ensure that all the cable routes are able to withstand decades of service.
Perfect. Thanks, Lawrence. Here's another one for you. What is the difference between our two projects, the Aquidneck project and the Falmouth project? If you can just speak to some of the differences.
I think it's important that this project going into Brayton Point is directly into an existing coal plant, decommissioned coal plant site. It's an important interconnection, one of the strongest, most robust interconnection points. So it has a lot of benefits for those reasons. However, the Falmouth route is shorter cable route from the project into the shoreline. We can utilize a slightly smaller substation and other gear that way. And we can also supply energy into that sector of the Southeast SEMA district through Falmouth. Those are some of the obvious ones. We can go over more, but I'll drop it there.
Thank you. And we have time for one more question during this session. And our last question will be a bit longer, so we can get to more questions. Another one for Lawrence. Could you provide more information that supports the intermediate onshore route across Aquidneck Island? Why did we choose to do that? And maybe what are some of the routes that were eliminated?
Yeah, glad to. This has been an ongoing period of study. The most obvious route would be to go up on the west side, but the Navy requested that we not run a cable near their facilities. Any of the routes up north have a lot of sensitivities and longer around Providence and other areas through the fairly deep channel of Mount Hope Bridge. Going up the Sakonnet River is very deep. The ground and seabed within the Sakonnet, as you go north of the groin and through the old bridge area, that's just about in the center of the screen there, you're looking at 50 feet of depth. You're looking at a hard bottom that is really difficult for us to bury the cable. And the goal is to produce a long-term project where we make the installation, we make it with minimal construction impacts, impacts to stakeholders and users of the area, and then it's done. There would be a real concern for the need to do ongoing maintenance to ensure that the cable remained buried throughout that period. It would also have the difficulties during construction of the old stone bridge, which was demolished in place. The debris, stone, concrete, rebar, and other remains on the seabed floor and would have to be moved in order to clear the area for us to come through with those cables. It's an intense recreational use. The current and fisheries right around the groin and the other currents on the tidal flows Those are some of the major points of why the Secana did not work at the top. The ability to come across Aquidneck with the use of HDD means you're underneath moorings, you're going underneath the beach, underneath the, if I may, the boardwalk by Park Ave, and you're not disturbing that. You're not changing those structures. You're 20 foot under that seawall. You are then able to make a pretty discrete trench alongside the road. You're still going to have one lane of traffic open. You're not going to prevent people's ability to conduct their lives. And then again, on the north side, you're utilizing HDD to go underneath and come out and proceed north into Brayton Point.
Excellent. Thank you so much, Lawrence. And now I'll hand it back to Chris for the last segment of our tour.
Well, thank you for the questions. And that's a great segue, actually, to our next position. So let's move on ahead to those HDD exit points that Lawrence was just mentioning. And what we'll now take a look at are the cable trajectories from each of those potential exit points. And you can see the exit borehole reaches down to about 40 feet deep below the bottom and then rises up to about 6 feet as the cable enters Mount Hope Bay, and then the route transitions to the northeast. The export cable corridor resumes its course, travels well east of Spar Island in Rhode Island state waters before entering Massachusetts state waters. The preferred route for the offshore export cable corridor, cables would proceed westerly, entering the mouth of the Lee River, and then the cables would make landfall on the westerly side of Brayton Point. The Lee River route is the preferred route as it avoids the main shipping channel in Mount Hope Bay, the turning basin, the shipping channel in Taunton River as well. The underground cables would make landfall using HDD at Brayton Point as well, and then transmit power via underground duct banks to a new HVDC converter station. The converter station site would sit on approximately 8 acres located in the central portion of the 300-acre site that is currently owned by the Commercial Development Corporation. The converter site would be immediately north of the location where the two 500-foot tall concrete cooling towers once stood. Now we're going to transition to just a few slides that can present some visual simulations of the converter station and the grid connection. This is an indicative HVDC converter station site, which is a specialized electrical substation that converts the power from direct current to high voltage alternating current, or HVAC, that allows for connection into the existing transmission infrastructure. The station buildings, as you can see up at the top right, would be built from pre-engineered metal or precast concrete, depending on the thermal design requirements. The station site does contain sound producing equipment during operation. As the station equipment and the site layout is further refined, Mayflower Wind will refine the mitigation strategies, such as low noise transformers or enclosing certain components or installing other sound barriers, excuse me, at the site. We'll also ensure that outdoor lighting at the converter station complies with local requirements. The majority of lights will just be switched on for only for emergency situations. Now, exiting from the converter station would be a new underground 345 kilovolt transmission line that connects to the existing National Grid substation at Brayton Point. The substation was previously used by the coal power plant. This will be repurposed as Mayflower Wind's point of interconnection to the New England grid. From there, the network of transmission and distribution lines connects electricity to customers like you. Now, to simulate visual impacts, these photographs and analysis were taken from some key observation points. The first, as you can see here, was at Brayton Point Beach. I want to take a few minutes to allow you to just look at both. This is now from South Swansea. Pointing on the red is the projected visual impact. Let's go back to the other one. And now the other one. So you may have noticed there was a tower next to the conifer tree and the concrete storage tank in the other view from Brayton Point Beach. But it's fair to say that the visual impacts will be barely visible from most of the surrounding landscape based on the topography of the woodland and the existing development. This ends our offshore to onshore connection. I want to thank you tonight, and I want to turn it back over to Kelsey for some more questions.
Thanks, Chris. So our first question I will go ahead and address. I mentioned that RPS is as a protected species observer provider. However, they are not a local PSO provider. Is Mayflower committed to local content and considering other PSO providers that are local on the South Coast? Happy to address this question. Mayflower is definitely committed to local content. We've committed that at least 75% of our operations and maintenance workforce will be locally hired here in Rhode Island and Massachusetts. We've also partnered with several South Coast organizations, including the South Coast Community Foundation, BCC and their National Offshore Wind Institute, the Mass Hire Greater New Bedford Workforce Board, and so on. One good partnership that I'd like to highlight is our one with Gladding and Hearn Shipyard. We've partnered with them to build a CTV or crew transfer vessel that will be utilized in our lease area. That's just one example of jobs and work going to the South Coast. So we're definitely committed to local content where we can find it. And now I can move ahead to the other questions. Here's one for Joel. What will our effect be on Muskeget Channel? For those who don't know, Muskeget Channel is the body of water in between Martha's Vineyard and Nantucket. A lot of people are worried about the backup of marine traffic in that area.
Yeah. So in terms of just in terms of vessel impacts, that's a piece that is addressed in our construction and operation plan. So based on construction scenarios and then ongoing maintenance that we were talking about earlier, there's projections in the COP that look at the number of vessels. And then obviously when you look at it beyond Mayflower, there would be vessels from other offshore wind farms and developers that are constructing their projects as well. That combined with fishing vessels adds up to sort of that larger picture. So I would point you to the construction operations plan for the estimates of the number of vessels.
Thanks, Joel.
Yeah.
Here's one for Lawrence, and it's kind of a repetitive one, but I think there's still some confusion. Lawrence, will we be using both Portsmouth and Falmouth for our projects or just one? Maybe you can just speak to both of the projects and the need for both of the projects.
Glad to. I look at it this way, is Mayflower is one lease area in the ocean, and we believe that with current and future wind turbine technology that might have a capacity of 2,400 up to 2,400 megawatts. On the other side, ISO New England limits the interconnection capacity to 1,200 megawatts. That's the most you're allowed to inject in one substation, one interconnection point. So that puts us in a situation where we may run the 1,200 to Brayton. We may be able to run 1,200 to Falmouth. I think there was another reference to why not try to bring it all into one location. It is possible for the ability to run into other locations. I know there are other connections around Brayton from other developers. So I think in summary, these are the issues that we need to do to make sure we bring the lowest cost energy from the lease area and follow the ISO New England and other regulatory rules.
Great, perfect. Thank you for that clarity, Lawrence. Here is another one for you about our HVDC converter station. You mentioned that Mayflower will mitigate sounds from the substation, but not eliminate. How will residents abutting the substation manage to have peace and quiet, especially at nighttime?
Yeah, good one. The converter station is similar to substations that we have in our current environment that we live near, work near, play near. The Somerset rules are very clear on sound impacts and sound emissions from our converter station area. So we will be meeting those. We have conducted measurements at the quietest times, at 3 in the morning in other areas, and ensuring that it was not conducted with any activities going on at Brayton Point. And we will have to meet, as I said, the Somerset stated regulations around those facts and figures. Another important point is that our converter station is well within the borders of the Brayton Point original site. There's a large berm between the converter station and the closest residence. So it's quite ideal as far as the ability to ensure that the impacts are not felt by the residents.
Great. Thank you, Lawrence. That was an important one. Here's another one from you. Not sure if you'll quite know the answer, but I'll give it a shot. Will battery storage technology be utilized at the HVDC substation at Brayton Point?
It may be in the future. We have considered it. It's, as we all know, a fast-moving technology and may have some benefits. And Mayflower is always maintaining its cutting edge. At this time, we do not have it included in our project.
Great. Thank you, Lawrence. Here is another one, I think for Lawrence, but Tim might want to jump in. Since we're proposing that the cabling will come up through the Saconnet River, what impact will this have on recreational activity during construction? Will areas be blocked from various boating and other water recreational activity? In what way? Actually, Joel, you might want to answer this one.
I can handle a little bit of that, and then Tim, if you want to get into some of the construction, you definitely feel free to do that. But just want to say again, so like with the lease area, especially after installation in the cable corridors, recreational boating, recreational fishing can continue just as they did before. There might be some of those temporary rolling safety zones, which we made as small and as short of duration as possible. But Tim, if there's any specifics around construction or scheduling, things like that, please feel free to jump in.
No, I think you covered it well, Joel. And we expect the cable installation period to take probably 6 to 8 weeks in the Saconnet River and similar in Mount Hope Bay. But the emphasis there is that these safety zones that we do plan to implement will be localized as much as they can. So not blocking off the entire river for the entire construction period. So we really want to work with work to implement these for the safety of mariners, but as local as possible, right? To minimize the impacts.
Great, thanks both. Here's one for Lawrence. Assuming that seawater will be used as cooling water for the offshore DC converter station, what is the approximate volume of water? I'm not sure if we know that. And what temperature will it be returned to sea? This person is concerned about the impacts that might have on marine species.
No, that's a good question. And yes, we will be using a heat exchanger style similar to fishing vessels and commercial vessels, where you ensure a full separation of the cooling water in the plant with the seawater so that they never are mixed. The actual volume is not yet determined. That's going to be part of our design effort, and glad to get back to you on the actual quantity. The temperature rise will be very minimal to ensure that it meets all the regulations. And as referenced again, we're under very strict codes provided by BOEM, Bureau of Ocean Energy Management, and other regulators.
Great, thanks, Lawrence. Here's another one. What time frame do you anticipate becoming operational for this South Coast project?
The project, working backwards, is our power purchase agreements that we've agreed to sell the electricity to the utility. They've asked us to meet what's called COD, commercial operation date, in late 2027. And we will be working through the construction periods in 25, 26 to meet that timeline.
Great. And where will our staging area be for transportation of the windmills? I think this is hinting at where is our staging and construction port.
I'll take a start on that and then my colleagues can jump in. This project will use a couple methods. First and foremost, we're going to use some method which is direct delivery. We'll actually have it come from the fabrication plant. This is in our normal world now a world project. So materials will be coming from a variety of areas and come via vessel and go right to site. For example, the turbine foundations, some of the tower structures and other areas. In addition, we will have a capacity and have secured the ability to use portions of the Port of New Bedford for handling other logistics.
Great, thank you, Lawrence. Here is one for Tim, and we're focusing back on Portsmouth. The landfall in Portsmouth indicated is on a beach used by the public. How deep will the cabling beneath the ocean bed be at this point? And will the construction have any impact on the use of the beach, either temporarily or permanently?
Yeah, thank you for that question too. So beneath the beach, I believe as Chris mentioned earlier, the cables will follow an arc trajectory under the beach and will, go to a maximum depth of approximately 40 feet below the seabed. But depending on the location, that may that'll decrease in depth closer to shore. So likely at least 10 to 20 feet below the beach at a given location. The beach will still be available for use during the HDD construction period. However, there may be limited disruptions to road access and traffic near the site during the HDD construction period to ensure the safety of the operation. So Mayflower and its contractors will work with Rhode Island DOT, the Turnpike and Bridge Authority, the town of Portsmouth, to plan road use and develop a traffic management plan to make sure that these impacts are anticipated and managed.
Great, thank you, Tim. Here's a quick one I can address. Does Mayflower participate in the Massachusetts Clean Energy Center internship program? We do not as of now, but we do love that program. I was actually a Mass CEC intern before I joined Mayflower Wind, and we are looking forward to bringing more interns on our team as our project continues to expand. And the second part of that question was, are there any activities taking place in New Bedford this year? There will be events taking place in New Bedford. We were just at the State of the City event in New Bedford last week, where the mayor gave a great address, including offshore wind. I don't have anything off the top of my head, but we will be having events in Fall River, Somerset, Portsmouth, and New Bedford. Here's one for Lawrence. Is there a PPA or a power purchase agreement in place for all 2,400 megawatts?
We do not have a PPA for the entire lease area potential capacity. In detail, Mayflower Wind was fortunate to win what's called 83C2 and 83C3. Those are the two procurement RFPs that Massachusetts issued, and those were 800 and 400, meaning the 1,200 total that will be going to Brayton Point.
Great, thank you, Lawrence. Here's another one from you, and you can take your best shot, and I'm happy to support as you need. What are the benefits for Portsmouth and Somerset broadly that will come from this project?
I think the ability to continue, especially around Somerset, going from some of its previous power generation to modernizing and taking on offshore wind, having their local vessel and maritime manufacturing facility, taking the site at Brayton Point instead of having it decay, to rejuvenate and bring in a converter station that is has limited activity. Once it's built, you're not going to have a lot of traffic. It's going to sit quietly and do its job. We have the ability of bringing in jobs and opportunities around Rhode Island throughout the area, pushing on local contractors. You spoke about it earlier, Kelsey, but that's a strong commitment from the group, and some of the work we've been doing in vendors in procurement on how we want them to look into very small and continually dig down, that the contractors do not need to be large conglomerates, but focusing on local. And the fact that even if you're in Aquidneck or Portsmouth, these green electrons coming into Brayton Point are green electrons and renewable energy that are spreading right through our grid. So we benefit because we know the electricity flowing on the grid doesn't know state borders or any of the actual utility or consumer that you may be. I'll pause there, Kelsey.
Great, thanks, Lawrence. Here's another quick one for you. Does Mayflower need any special permits in Portsmouth to work? Is the public able to offer any input about this?
We'll be going through all the standards, starting from the federal down to the state, and then through the local requirements. For example, we've already secured several local permits in order to conduct archaeological investigations. We continue to work with the town of Portsmouth, communicating with them, and the town of Portsmouth has its set of committees and ordinances that offer opportunity for the public to participate.
Great. And here's one of our last questions. Feel free to take a shot at this one too, Lawrence. What are the next steps in our process in terms of where we are in permitting and just what's next for the communities?
Yeah, I think, if I may, it's a chance, you know, Mayflower is 60, 70 people. We have a really strong permitting group. We have the opportunity of using the outreach group to communicate a strong technical efforts, and the whole ability to move forward at this stage, because we're shifting from determining what the project is, focused on the lease, winning the awards, securing the PPAs. It's now to design the system and really narrow in, and that's what's important about engaging in the public to talk about what we plan to do, because we're now beginning to know what we plan to do and make sure we're making the right decisions on that front and engage with stakeholders. The permitting team is going through all the formalities. Permitting is a long, deliberate process over 2, sometimes 3 years. So we've got to really work through all the efforts there as we get lined up for commitments to vendors and preparing for that construction that we referenced in the 25-26 period.
Perfect. Thanks, Lawrence. The last question that we have, will the slides and or recording be available? Yes, both will be available after we finish tonight in the next couple of days. So with that, we're basically out of time. My apologies if we didn't get to your question tonight. Please feel free to email us or follow up with any questions to info@mayflowerwind.com or call the number on the screen, or feel free to come visit our booth this Saturday at Somerset SouthCoast Open Air Market. We're looking forward to being there for the first kickoff weekend. We'd also like to urge you to follow us on our social media pages displayed here, as well as subscribe to our newsletter to stay informed about the project updates and future events like this one. Also, if you're a supplier or contractor, we do have a supplier and contractor page for you to submit your information if you're interested in working with us. From all of us at Mayflower Wind, we'd like to thank you again for joining us this evening, and we really hope to see you all again soon. Thank you.